Hello there! This video is all about quasi-experimental and experimental research. And keep in mind that experimental research is the gold standard in terms of research methods that provide the opportunity for the researcher to make causal inferences, or to say the independent variable caused the dependent variable. So I'm going to go over all of the requirements for a true experiment that would give you the opportunity to make that causal inference, and then provide an example of experimental research. And then I'll give you an overview of two more advanced experimental designs, where we have the factorial or two-factor experimental design, and then my personal favorite, the Solomon four groups design for experimental research. And then I will show you the two different types of quasi-experimental research that are most common in behavioral sciences, the pre-test and post-test, and pre-existing groups, and provide an example of each. And then I will dig into what it's all about with experimental manipulation and control, and what manipulation means, and how manipulation is really what sets quasi-experiments and experiments apart from other designs. And then I'll give you an opportunity to test your knowledge. So let's begin with experimental research, or true experiments. True experiments have the highest level of internal validity because there's less bias and more causal inference involved. And this is because true experiments include manipulating the independent variable. You do not simply measure it naturally and look at naturally occurring predictors of your outcomes of interest. You make sure a researcher is in direct control of the independent variable. True experiments also exert control over extraneous variables that may influence the observed differences in your dependent variable between the conditions of your independent variable and become a confound. Confounds are any variable that's systematically related to your independent and dependent variable and can influence your results. And there's many ways to control for extraneous variables, and I'm going to cover the most common ways. So one way to control for extraneous variables is through random assignment to conditions. You're really controlling for individual differences among the participants in your sample by doing that. You do not rely on pre-existing groups or clusters, and you make sure everyone in your sample has the same or similar chance of being included in each condition, and hope that each condition has a similar mix of differences in attitudes, perceptions, experiences, and demographics. An even better strategy is to strategically assign participants to make sure that conditions include similar people, so you can match your conditions based on variables relevant to the study. Another way to control for extraneous variables and prevent them from becoming a confound is by ensuring that the only difference between conditions is the manipulation of the independent variable. Ideally, study participants in the sample should have the exact same experience in every condition. So for example, research takes place at the same time of day, in the same type of environment, with the same researchers who directly interact with participants, and the same measurements of the dependent variable. So everything other than that difference in the independent variable is the same. Ideally, experiments also have a control condition who receive no manipulation of the independent variable, or some placebo that's similar to the real intervention, but is benign and not really expected to have any effect on the dependent variables. This also helps control for extraneous variables because the control condition serves as a baseline to compare your treatment or experimental conditions to. But keep in mind that a study does not have to control for extraneous variables in all the ways to be a true experiment. Different experiments lend themselves to various forms of necessary control. So the classic example of a true experiment may resemble something you did for the science fair in middle school. Here the dependent variable is plant height. The independent variable is fertilizer. And you can see here that there are 3 treatment or intervention or experimental conditions, however you want to label them. And we have one that gets 2 drops of fertilizer, one plant that gets 4 drops of fertilizer, and then another that gets 6 drops of fertilizer, plus your control condition who got no fertilizer at all, that first condition there. And that's your baseline growth. Ideally, you would have multiple plants in each group that were randomly assigned to conditions, or 4 clones, which would not be possible in human subjects research yet. But to be confident in your results, you must make sure that the plants get the same level of light, the same amount of water, the same type of soil, and really the same everything except for the amount of fertilizer. It's also best to have a control group or a plant that receives no fertilizer, but gets the same experiences as the plants in the condition who received the fertilizer, as you see there. Here's a people example. So let's say that Starbucks is conducting research to see if caffeine improves performance for a sample of factory workers. Here, your dependent variable is performance, and it's operationalized as the number of error-free parts completed in a week. And the independent variable here would be caffeine. And there's two conditions, the decaf house blend, which is like our control, and then our Cafe Verona dark blend, which is our intervention, and it's served twice a day for a week. You would need to have factory workers randomly or strategically assigned to conditions in an effort to evenly distribute any pre-existing individual differences between conditions that could maybe influence the results and become a confound, like motivation or years on the job or age or even caffeine tolerance, right? You want to evenly distribute those characteristics between your two conditions. Here, it's nice that the research focused on factory workers exclusively in terms of control. Maybe not so much if you want to generalize the results to other types of employees, though. But also make sure that participants in both conditions have the same types of work tasks and demands. This study uses a placebo by having the control condition drink something that tastes like coffee and maybe telling them that it's coffee. And that also helps you rule out any question that simply drinking hot brown liquid or thinking you're getting caffeine is what led to any observed differences in performance between conditions, right? We're controlling for that placebo effect in this example. Now let's take a look at an example of experimental research that hits home for me because I am an Ohio native, Southern Ohio specifically. And when I went out to the West Coast for graduate school and for my first job, I had people coaching me up on how to talk all the time. My best friend from graduate school couldn't believe that I said collar to talk about, what something looks like instead of color, right? She's like, a collar's for a dog. Color is, the color of something. So I learned many lessons and I found out quickly that having an accent may make people have certain judgments about who you are as a person and how capable you are. So take a moment, and maybe even pause this for a moment, to read the abstract and think about what is the independent variable and the dependent variable here. Okay, so hopefully you tried it on your own, but I'm going to focus on the highlighted area here. So we were looking at the effect of Southern accent on perceptions of speaker competency. And it looks like Southern accent had two different conditions, Southern and neutral. So Southern accent, or accent really, is our independent variable. It is the manipulated cause that we're looking for in this study. So there's going to be two different conditions of the independent variable, Southern accent and a neutral accent. Then our dependent variable is perceptions of speaker competency. And let's take a look at the next slide to see how speaker competency was operationalized. Let's take a look at the sample and measures for this research. So their participants were 21 men and 43 women from moderately sized Southeastern University. You can think about how well that sample would represent the entire population of people in the South or of people in general, right? Probably not so great, but it's probably a convenient sample of who they had access to. 83% of participants were describing themselves as Southerners. So this would be it'd be better to tap into the Southerner population than others. The independent variable here is the type of accent, right? So either a Southern or a neutral accent. And keep in mind that both conditions had an identical script and also an identical voice, just the accent changed. The dependent variable was the perceived level of competency. So after people listened to those scripts or whichever script they received, they then did a survey to rate how competent they thought the speaker was. And they rated them on all these different things here. So were they a reliable source of information, grammatically correct, unknowledgeable about the subject matter, effective instructor, persuasive presenter, unprofessional manner, articulate speaker, and unsophisticated demeanor. And you can see they used a 1 to 5 scale with higher scores indicating higher ratings for each type of perceived competency or incompetency. So now take a moment to pause and read about the procedure for this experiment. So you can see that they listened to an audio recording and then they completed questionnaires, probably in a lab. You can see that they randomly assigned half to receive a Southern accent in the audio, and then the other half listened to a neutral accent. You can also see that they exerted some control Both conditions included people with similar characteristics, right? That happens a lot of times with random assignment. And both conditions heard the same man's voice, just with a difference in accent. You'll also notice that they used deception here. They told people who came to the lab that they were going to be doing an experiment assessing verbal versus written stimuli, and that they were assigned to the verbal condition. Because if you told people that they were going to be assessed to see how accent influences their perceptions, that might have biased the results. I'm sure after the study they were debriefed and told what they were actually doing in the study. So here's a table of their results. So let's take a look at the p-values, right? The p-values and the means for each group. So you can see that we've got all the different ratings of competency listed, and then for each we have a p-value, then the mean for the folks in the southern condition, and then the mean for the people in the neutral condition. So you can see that those that heard a southern accent thought that the person was significantly less grammatically correct, was a significantly less effective instructor, and was significantly more unprofessional, significantly less articulate, and sophisticated, or significantly more unsophisticated, right? Those were the perceptions of this sample who listened to either a southern accent or a neutral accent. Also notice that there were no differences, no reliable differences, right? The p-value is greater than 0.05 in being a reliable source, knowledgeability, or persuasiveness. So overall, the results suggested that the participants viewed the southern speaker, or the person that was speaking with a southern accent, as less competent than the non-southern accent. However, it's weird, right? Because 83% of the sample self-identified as southern, but they still showed that negative stereotype. I really like this quote from Audrey Adkins. It says, "I say to you, my fellow y'allers and drawlers, be brave. Say your smart things in your smart southern accents, and don't let yourselves be homogenized. The cost is too high." Now that you've seen a pretty basic experiment, I want to introduce you to two more sophisticated experimental designs, the Factorial ANOVA and the Solomon Four Groups design. So let's take a look at Factorial or two-factor ANOVAs. So as the name implies, a factorial or two-factor ANOVA includes two factors or two independent variables. And it allows you to look at two independent variables at the same time to not only look at the main effects of both of those independent variables on your dependent variable, but also to see if your two variables interact to influence your dependent variable of interest. So as always, you would want to have random assignment to conditions. And here, since it's an experiment, you're going to manipulate both those independent variables. And you want to have some control so that, they're doing everything the same except for that difference in those two independent variables. So for example, let's say that we wanted to see if the attractiveness of a criminal and the type of wording used to describe the crime have an effect on how long people would recommend sentencing someone for the crime. So here, we're going to have four different conditions, right? Each picture kind of represents a different condition. So in one condition, you're going to have this picture, the ordinary fella, and when it talks about the crime, they're going to call it a robbery. In the second condition, you look at a picture of the same person, but this time, the crime is listed as a swindle, not a robbery. But everything else is the same in the description. In the third condition, now you get an attractive version of this guy. And check it out. It's the same exact face, except in one, it's kind of grayed out and plain and he's balding. And in the other, he's got stylish hair and he kind of looks like he's like at an important event or something. So in this third condition, they see the attractive face and the word robbery to describe the crime. And then in the fourth condition, they see that attractive face and they see the word swindle. So here, a hypothesis would be that people who see the ordinary face and see the word robbery are going to have longer sentencing. But the same isn't true when you see swindle, because swindle is a word that kind of makes you think of a slick person, right, that's trying to get away with something. And so their hypothesis would be that the attractive person in the swindle condition would get stronger sentencing, such that the type of crime and the attractiveness of the criminal would interact to result in those sentencing guidelines, right? So if you're an attractive swindler or an ordinary looking robber, sorry about your luck. So the Solomon four groups design, as you can see here, is a bit complicated and it requires a pretty large sample to pull off. But it is the best way to determine with certainty if an independent variable causes observed changes in a dependent variable. So in condition A, as you see here, that's your experimental group 1. They get a pretest. You measure the dependent variable, right? Then you receive the intervention, and then you receive the post-test. So you can see this is kind of like a mix of quasi-experimental research and experimental research, but with lots of control. So condition B, that's your control group 1. They get the pretest, then no intervention, and then the post-test. Condition C, your experimental group 2, they get no pretest, they get the intervention at the same time the other group, group A, gets it, and then the post-test. And keep in mind that these measurements should all be happening at the same time, right? The pretest should happen at the same time, the manipulation should happen at the same time, and the post-test should happen at the same time. All right, group D, that's your control group 2. That is the post-test only group. No pretest, no intervention, just a post-test. So if you find that there is a big difference between groups A and C and groups B and D, right? If A and C look a lot different than B and D when it comes to the post-test, this means that the independent variable probably had an effect on the dependent variable because group A and C received a manipulation of the independent variable, and groups B and D did not. But there could be other issues here that we have to control for with these other groups. So if we see a big difference between the post-test measure of the dependent variable for groups B and groups D, that means that the pretest influenced the post-test, right? Because in group B, they got the pretest, in group D, they didn't. And if you see big differences there, neither one of them got the intervention, right? So that would be a sign that the pretest had an influence on the post-test. And if this happens and you use the exact same pretest and post-test, you may need to create an equivalent or an alternative form for your post-test that has reliability and do the study again. All right. So if you see a big difference between the pretest measure of the dependent variable in group B and the post-test measure for the dependent variable in group D, this means that something happened in between measurements that had an influence on the dependent variable. You could also just look at the difference between pretest and post-test in group B for that as well. If you see a big difference between the post-test for group A and the post-test for group C, then that is a sign that the pretest influenced the effect of the independent variable on the dependent variable, because the only thing that differs between groups A and C is that group A received the pretest and group C didn't. So that means there's an interaction between the pretest and the independent variable that had an effect on your results. So by analyzing the data in this way, you can isolate, is the independent variable the real cause of the observed differences in the dependent variable while controlling for the influence of the pretest and external influences, which are confounds a lot of times in research. So now let's take a look at an example of a Solomon four groups design with some actual variables there. And this example is close to home for me because I am a faculty member who recently became certified in Quality Matters instruction, and I actually went through Quality Matters training, which is designed to help faculty members put together really good online courses that are engaging and easy to navigate and include some interactive components. So in this case, the independent variable is the Quality Matters training. That's what's being manipulated. And the dependent variable is the ratings on a Quality Matters rubric for faculty members' classes. So groups A and B have a pretest where they have their courses evaluated by the Design Center, and they receive detailed feedback about their ratings in the rubric. So they get a rating and they get their feedback. Groups A and C receive Quality Matters training the winter between the fall and the spring semester. So If Group A and C have much better scores at post-test compared to Groups B and D, then the trained group's performance is higher than the untrained group's performance, and it looks like the Quality Matters training improved Quality Matters ratings. If there's a large difference between the post-tests for Group B and Group D, the two control groups with no training, then it looks like the Quality Matters rubric feedback in the fall impacts Quality Matters feedback in the spring. Maybe the professors in Group B saw and took the first round of feedback to heart and made improvements without the training. Maybe the evaluators gave more positive ratings to classes and professors that they already evaluated, right? So there's many reasons why that might happen. All right. If we see large differences between the pre-test for Group B and the post-test for Group D, performance before training, then that means external events influence those Quality Matters ratings. So maybe there was a new requirement to meet Quality Matters standards of teaching online, and maybe there was even something happened like COVID, right? There was a rush to get all the classes in line. So an external event influenced those ratings. If we see a large difference in the post-test for Groups A and for Group C, then that means that getting feedback in the fall had an impact on the effect of the Quality Matters training. Maybe you're more attuned to the need for training if you got low ratings, or maybe you're less eager for training if you got high ratings to start with. So you can imagine the cost and the time associated with such a sophisticated design, but you can see with a practical example how it really does help you narrow down the causes of your dependent variable. Now let's take a look at quasi-experimental research, which has a lot of the same characteristics as experimental research, but is flawed in a way that limits our ability to make those cause and effect conclusions. Like experimental research, quasi-experimental research involves manipulation of the independent variable, but it often lacks randomization and/or control over many extraneous variables. So there are two major types of quasi-experimental research. One is the pre-test, post-test strategy, and this is where you get time series data by measuring the same group twice. So you measure the dependent variable, you manipulate the independent variable, then you measure the dependent variable again, maybe with a new measure that has alternate forms reliability, ideally. So for example, you could measure depression symptoms with the Beck Depression Inventory. So this would be your dependent variable that you're measuring. Then you could give participants in the study a psychedelic dose of psilocybin in a calm environment with 3 of their closest friends and family for the day. That's your independent variable. That's your manipulation. Then you could measure depression symptoms with the Beck Depression Inventory, again, your dependent variable, a week later. So this pre-test, post-test strategy gives the researcher control over pre-existing individual differences in the dependent variable. So you're controlling for pre-existing levels of depression. And this allows you to examine changes after receiving the independent variable, taking psilocybin. But it doesn't give you any control because you don't have a control group. So you can't see if people were less depressed over time without psilocybin, and it prevents you from being able to control for factors other than the psilocybin that they experienced in the study that may have influenced their depression, like completing the Beck Depression Inventory the first time, or interacting with other depressed people in the lab when they came in to do the study. And those things may have influenced changes in depression symptoms that weren't necessarily psilocybin. So it's got limitations compared to kind of the pre-test, post-test nature that you see in a Solomon 4 group design. So when it comes to statistics, this type of research would most likely require a t-test for repeated measures, and this would allow you to examine mean differences in the dependent variable at pre and post-test within each person. So I love examples. So here's some other example hypotheses for a pre-test, post-test quasi-experiment. So maybe you see my coffee meme there, right? So maybe employees will be significantly more productive after drinking coffee. So you'd measure productivity before and after drinking coffee. 10-year-olds will be able to run significantly faster after putting on Nike Renew Run Kids running sneakers than when they were wearing a Walmart brand sneaker, right? So you're measuring them 2 different times. First-year college students will have a stronger sense of belonging in college after watching a video of students sharing stories about the nervousness and apprehension they experienced during the transition to college. So you would measure their sense of belonging, the dependent variable. Then you would have them watch that video about student nervousness and apprehension, the independent variable. And then you would measure sense of belonging again, your dependent variable. The second type of commonly used quasi-experimental research involves a researcher manipulating their independent variable with different conditions, representing variations of the independent variable, but the different conditions are assigned to groups that are already formed for some other purpose, like departments or classes or companies or churches. Then you measure the dependent variable across these pre-existing groups that were manipulated in different ways to see if there are differences. A quasi-experiment with pre-existing groups could involve cluster sampling, where individual participants are randomly selected within pre-existing groups, and then different clusters would receive different conditions of the independent variable and maybe a control condition too. So cluster sampling and pre-existing group quasi-experimental research go really nicely together. Quasi-experiments lack that random assignment component to conditions, which can lead to really serious confounds and validity concerns. If you rely on comparing the dependent variable between pre-existing groups, even if you manipulate conditions in each group, you really can't be sure if the observed differences in the dependent variable are due to the independent variable or the other pre-existing individual or group-based differences that exist in those pre-existing groups beyond what was manipulated. So for example, you could give a group of tech support employees in the break room some high-test coffee, that would be your independent variable, and compare productivity, the dependent variable, which would be operationalized as the number of successful resolutions in the next 3 hours. And then you could compare them to employees who did not take a break and thus did not receive coffee. What are some issues with that? Think about it for a second, maybe even pause. What are some issues with that design of going to the break room, giving them coffee, right? And then measuring their productivity after the people who were already in the break room drank some coffee, and then comparing it to those who never entered the break room to get coffee? Well, break takers may be less productive than non-break takers, right? Before any coffee-related manipulation took place, they're more inclined to take breaks. Maybe they're not working as much. Coffee breakers also may be less susceptible to coffee manipulation because they're in the break room. They may be going there to get coffee already, and so they may have a tolerance to caffeine. So let's think about some more hypotheses that would be fitting for a quasi-experiment with pre-existing groups. So employees who are forced to do strenuous exercise on the clock for 30 minutes a day, 4 days a week in the accounting department will have less work stress than employees who are forced to rest on the clock 30 minutes a day, 4 days a week, the HR department. So here your independent variable would be what kind of activity they're doing, right? 2 conditions, strenuous or resting. And the dependent variable would be looking at work stress. But the problem is the exercise went to the accounting department and the rest went to the HR department. So maybe the differences in stress don't have anything to do with their activity and just the type of stress that happens for employees in those different departments. Another example hypothesis for pre-existing group quasi-experiment would be students who take a statistics class where collaborative or group testing is offered will have less test anxiety than students who take a statistics class where collaborative testing is not offered, which will be the next example I show you. All right. Also, if you think about the stats that you would need for this, chances are you'd be doing an ANOVA or a T-independent, where you're looking at significant differences between groups that you're measuring a numeric dependent variable. So here's some shameless self-promotion. I'm going to show you an article that I published with my colleague and the Dean of the School of Nursing at Nevada State in the Teaching of Psychology, titled Comparing 2 Models of Collaborative Testing for Teaching Statistics. So take a moment to read the abstract for this study and think about how many conditions there are, what's the independent variable and dependent variable, and just get a general idea of what the study involved. So pause this and take a look at the abstract. All right, so here you can see that the independent variable is the type of testing. And you see that there's 3 conditions of that, right? So one is you take a group test before your individual test for all the tests in statistics. Another group of statistics students were in the individual testing first condition, where they took individual tests before group tests. And then our third group was our control group, who received no collaborative testing and no group testing. All students in the collaborative testing group either group first or individual first in both of those conditions, took the same survey, and all students in the convenience sample were taught by me with the same lecture videos, the same assignments, the same class activities, and the same tests. So this study did have some degree of control, even if participants weren't randomly assigned to conditions. And I will admit that my control group was taught the semester before I did the collaborative testing research. And so maybe that semester before in the control group had some other things going on, because I do notice differences between fall and spring semesters. So just some things to keep in mind of why this is not a perfect true experiment. It lacks that random assignment to conditions because I was relying on my clusters or my classes. So now let's take a look at the results for this study. And just because I can't help myself, I'm going to stats nerd out with you for a moment. Notice that in that first table, we did t-tests because we were comparing the group first to the individual first conditions, and there were only 2 groups there. And then in the second table, we used an ANOVA to compare the group first versus individual first versus the collaborative testing group because we had 3 groups there. So I want to draw your attention to some specific columns here, but before I do, let me just explain how to look at this table. So you see the measure. These are all your dependent variables listed here. And then here we've got our different conditions listed. So you see group first versus individual first versus this one, individual only, was our control group in the semester where we didn't do collaborative testing at all. So now let's take a look at that p-value column. And just remember that if p is less than 0.05, then you conclude you have significant or a reliable difference between conditions, because the probability that the results are due to sampling error or some other noise is less than 0.05 or less than 5%. Also take a look at our measures of effect size. So you can see R squared for the t-tests and eta squared for the ANOVA. And remember, these tell you the percentage of differences in the dependent variable, or the measure, that are accounted for by which collaborative testing condition the students were in. Also remember that because we don't really care about effect size that much unless results are statistically significant or reliable, we only reported R squared or eta squared for the findings that were statistically significant with a p-value less than 0.05. Another place to look is the mean columns. So see the means for each condition. And remember that a higher mean represents a higher level for whatever dependent variable was being measured. So if we look at these results, compared to students who took their tests individually before taking it as a group, so in Table 1, students who get to take quizzes with a group before taking them individually tend to give better course evaluations, feel that collaborative testing helped their stress and anxiety, and thought that collaborative testing was more useful in general. If you look at Table 2, you'll see, if we just focus on those p-values that are less than 0.05, those significant findings, students who took their tests as a group before taking them individually also had a significantly better grade on individual tests and overall grades compared to the students who took their tests individually before taking it as a group, or students who did not have any collaborative testing and took all of their tests once individually. So you can see kind of what the results would look like when you are comparing different groups. And if these groups were randomly assigned, this would be a true experiment, but they weren't. The group first, individual first, and individual only conditions relied on pre-existing classes that I had. So now let's bring it home by thinking about experimental manipulation and control and how they kind of vary between quasi-experiments and true experiments. Also thinking about how manipulation and control are also the hallmark of experiments and quasi-experiments. So the major distinguishing characteristic between descriptive, correlational, and non-experimental research and quasi-experimental and experimental research is that the researcher manipulates or inflicts the independent variable or different levels of the independent variable on research participants in the experimental and treatment conditions. So for example, if we have an experiment examining differences in student quiz grades and how long it took to complete the quiz based on room temperature, right? Our dependent variables are grades and how long it took to complete it, and our independent variable is room temperature. The researcher could manipulate the room temperature in 3 different conditions, hopefully randomly assigned if it's an experiment, or in pre-existing classes if it's a quasi-experiment. and then compare overall mean quiz grades and the time to complete the quizzes across those conditions. Maybe your big hypothesis is that students taking the quiz in a warm, green temperature room have better grades than students taking the quiz in a hot or cold room. Ideally, research strategies exert control over all non-manipulated variables such that all participants have the same experience, except differences in the manipulated independent variable. If the researcher used a quasi-experiment to examine the impact of room temperature on quiz grades and relied on pre-existing groups or different classes, it would be really difficult to know if observed differences in grades were due to the temperature in the room or to a whole host of extraneous variables like class subject, quiz difficulty, the professor, the time of day, or the student major, for example. It would be much better if the researcher used a true experiment to randomly assign 1/3 of the students to each of the temperature-based conditions, and then have them take the same test at the same time of day, in the same type of room, with the same time limit. A true experiment like that offers more control over those extraneous variables that may influence your results and become confounds. Ideally, research strategies involve a control condition who receive a similar manipulation that is missing the key ingredient of the independent variable, or a placebo, and they also receive normal or standard conditions. So, for example, I conducted an experimental research project on implicit or unconscious bias against women and ethnic minorities in STEM, science, technology, engineering, and math. We used an online experiment programmed in Qualtrics. The sample was randomly assigned to one of two conditions. Both conditions completed an implicit attitudes test measuring their association of personal pronouns, me or I, and other pronouns, like they or them, with words that were commonly associated with the humanities, like art and literature, or words associated with STEM, like science and computers. The IAT measured how strongly the attribute words, me or them, are associated with the target words, from humanities or STEM, based on the mean latency, or how long it takes to categorize the words properly. People assigned to the experimental or treatment condition read about 3 Latino women and 3 Black women who made advances in STEM. The control page included the same number of facts and statistics, but these were about flowers and included 6 photographs of flowers with brief descriptions, instead of talking about women and minorities in STEM. Based on the lack of women and minorities in STEM fields in previous research, we hypothesized that the mean latency would be greater for women and minorities when pairing me with STEM as opposed to pairing me with humanities, but that the intervention, the information about the female minorities in STEM, would reduce the latency. The results suggested that people who identified as Asian or white identified more strongly with STEM than people who identified as Black or Latino, and that an intervention consisting of materials depicting successful Black and Latino women in STEM really did increase implicit associations with STEM themes for all the people, regardless of race or ethnicity. So you can see here that we used that control condition that was really similar, but was pretty benign. Flowers aren't going to have an impact on your attitudes towards STEM. So let's end this video with an opportunity to think about it. So I encourage you to pause and read this scenario and see if you can answer the questions. Some of them are review and some of them are directly from this video. All right, so hopefully you tried it on your own, and I'm going to go over the answers for you. So what is the independent and dependent variable? Here the independent variable is the belongingness intervention. So there's 2 conditions, right? There's the intervention condition that actually receives the belongingness intervention, where they get to read about stories from Marshall students who felt apprehensive about college belonging and were writing about their own feelings about transitioning to college. And then the control group, who gets a benign intervention, which is looking at, technological things. And based on past research, sharing technological difficulties is not likely to influence student retention. The dependent variable is student retention, and it's operationalized as completion rates, or the percentage of students who completed the first year and enrolled for the next semester. Here, the sampling strategy was probably a convenient strategy because Julia had access to students at Marshall University. In this situation, it is an experiment. It's a true experiment. There was manipulation of the independent variable and randomly assigned conditions of students who had similar experiences in the study, other than the intervention received. And all students were from the same institution, and pre-existing groups were not compared. So any systematic, significant, or reliable observed difference in retention between the conditions was likely due to the intervention and not some other extraneous variables. So the type of data collection that was used was a programmed experiment. So all of the random assignment and interventions were online. And then the limitations of the sampling strategy and data collection method would be that she used a convenient sample, right? She has strong internal validity. You can make pretty accurate conclusions with the study, but the convenient sample at Marshall University may not represent students in online degree programs at other institutions, which really does appear to be her population of interest based on the first sentence of the experiment description, where she's talking about students enrolled in an online degree program, not just Marshall students. But if her sample or if her population was truly just all MU online students, then her sample would represent them pretty well because she appears to be including all incoming students in her sample. So this data collection method is pretty valid, but would probably benefit from measuring and controlling for other variables to examine their influence, instead of just hoping that random sampling eventually, evenly distributes those individual differences among participants and conditions. But overall, a pretty solid study. So I know this was a long video, but I hope that you enjoyed seeing some examples of experimental and quasi-experimental research in action, and you feel more equipped to conduct that kind of research or to critique research that you see elsewhere.